Hi everybody. In our previous session we have discussed about charge and properties of charge. Do you remember? Yes, we learned what is charge and what are the different properties of charge and how to calculate amount of charge on a body. So how to charge a body positively or negatively, these all things we have discussed. Today let us discuss about Coulomb's law. Today we are going to discuss about Coulomb's law. So this is a very important one in electrostatics or a static electricity lesson. We learnt in our earlier classes that like charges repel each other and unlike charges attract each other. Means what? For example, if I have a positive charge and another positive charge, so these two positive charges repel each other. Here repelling, or if you take another set of positive charge and a negative charge, these two will be attracting. So here we are using words called repulsion and attraction. What are these two? Actually these two are resembles force. These two are not force, these are force, repulsive force or attractive force. This force, the force acting between the two charged particles, we are calling as electrostatic force. Which force is that? Electrostatic force. Simply I am writing as electrostatic force, ESF. So this electrostatic force, for this electrostatic force, Coulomb has given a law. So the experiments of Coulomb established a relation, the force between 2 point charges at rest. This electrostatic force, what we are calculating by using Coulomb's law, holds for a charges which are at rest, and those charges also point charge. Remember this, point charges at rest. When the point charges are at rest, we can apply this Coulomb's law. So what is this Coulomb's law? Now let us see the statement of Coulomb's law. Statement of Coulomb's law. So let me explain that. So according to him, when two charges Q1 and Q2 are separated by a distance r, then the force acting between them is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So let me give explanation, mathematical explanation for that. For example, let us take two charges. This is a Q1 and Q2. These are the two charges. Sir, you said that this is applicable for point charges and you are drawing spheres. So here what I am taking is, I am considering these as a point charges. The whole charge is concentrated at the center of the charged particles. Remember that one. So that's why. So it has a charge of Q1 and another charge is Q2, and the distance between their centers is r. Remember this, r is the distance from the center of one charge to center of another charge. It is not the distance between the surfaces, whatever it may be. Okay, so it is a sphere or cuboid or something, whatever it may be, always we will be taking from their centers, because we will be considering these as a point charges. That's why the distance is measured always from the centers of the bodies, charged bodies. So Q1 and Q2 are the charges on each bodies. Now there exists a force between them. It can be attraction or it can be repulsion. So the attraction or repulsion force F is directly proportional to product of the two charges Q1 into Q2. This is the first one. And the electrostatic force, attraction or repulsion, is inversely proportional to square of the distance between them. This is I am taking as equation 2. So this is Coulomb's law statement. The force of attraction or repulsion between the two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. So it also called as inverse square law. It can be called as inverse square law. You remember that. Now from these two equations, one can write F is proportional to Q1 Q2 by R square. You know it very well how to write it. So from these two equations I am writing F is proportional to Q1 by Q2, Q1 Q2 by R square. So here is a proportion. So by taking out this proportion, we will be keeping a constant in mathematics or physics, or when you are solving the equations, we know that very well. So here also I am doing that F is equal to, I am writing a constant, I am taking a constant called A into Q1 Q2 by R square. So A is a constant here, so that this A can be written as experimentally as F, Q1, Q2 and R. These four quantities are independently defined quantities. These are independently defined quantities. We have a separate meaning for these all, so that the constant A can be measured experimentally. So in SI, if you take all these quantities F, Q1, Q2 and R in SI system, then in SI the constant value A is measured as 8.9 into 10 to the power of 9 Newton into meter square by Coulomb square. This is the unit of this proportional constant, Newton into meter square by Coulomb square. How did I get it? So from this formula, if I write formula for A, what will be the formula of A? F into R square by Q1 Q2. Am I correct? Formula of A is, I am writing here simply F into R square by Q1 Q2, right? Now what will be the unit of A? Unit of F. What is the SI unit of F? Newton into unit of it is a distance. Unit of distance is meter. So as R square meter square divided by Q. Q is the charge. Charge unit is, SI unit is Coulomb. Coulomb into Coulomb, Coulomb square. In this way you can write the unit of A as Newton meter square by Coulomb square. So approximately while you are calculating, its value is taken as simply 9 into 10 power 9 Newton meter square by Coulomb square. This is the value of A, proportionally constant. So it can be written as later A value is 1 by 4 pi epsilon naught. How to read it? 1 by 4 pi epsilon naught. This is epsilon and 0 I am keeping here, it is called as epsilon naught. So this value is how much? 9 into 10 to the power 9 Newton into meter square by Coulomb square. So the finally the magnitude of electrostatic force can be written as 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the formula used to calculate the magnitude of electrostatic force acting between the any two charges separated by a distance r. This is the formula we will be using while calculating the electrostatic force magnitude. Here I am calling this is only the magnitude. Then what about direction? We will see later that one. So here let us see an example. So how to calculate it? For example, let us take two charges of this is one charge and this is another charge. These two charges are kept at a distance of 2 meters, and charge on the first body is Q1 I am taking as plus 6 Coulomb, and charge on the second body I am taking as minus 4 coulombs. Now I want to calculate the force between these two charged particles. Can you tell what kind of force is this? Is it attraction or repulsion? Very good. So as these are two unlike charges, this is positive and negative, then the force is attractive in nature. Now let us calculate the magnitude. So how to calculate magnitude? So we will be using this equation. F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. So 1 by 4 pi epsilon naught value is 9 into 10 power 9 into 6 into 4. I will be taking only the magnitude of the charge, 6 and 4. No need to take its sign, because we know the sign indicates that whether it is a attractive or repulsive. 2 square, it is 4. So if we simplify this, how much are you getting now? It is 54 into 10 power 9 Newton is the magnitude of force, electrostatic force acting between in this example. Understood everyone? Right. So here the force is attractive if the charges are unlike charges, means one is positive and another one is negative, then the electrostatic force is attractive in nature. What is this? Attractive. Okay, if the charges are like charges, then what is that? Guess it? Very good. Repulsive in nature. Understood now? So in this way one can calculate or one can solve the number of problems based on this Coulomb's law. If you know the values q1 q2 r, you can calculate. Sometimes they will be given q1 q2 f will be given, they will be asking you to calculate r value. So by using this equation easily you can solve. Remember that while substituting the values, see that all the values, given values are given in SI units or not, because you are substituting a value in SI, 9 into 10 power 9. So that all the values q1 q2 are values you need to convert into SI system. Okay, remember this point. All the given values should be in SI units. Given data should be in SI. If it is not given in SI, then what you should do? Very good, you need to convert. Very good. Okay, so in this way we can solve problems. Understood everyone? Very good. Now here F is giving only the magnitude of force now. What is giving, sir? Magnitude. Right, here 54 into 10 power 9 Newton is the magnitude. Where is its direction? There is no direction for here. But we know that F is it's a vector quantity. Force is a vector quantity. Yes or no? Everyone knows that. So as force is a vector quantity, it has magnitude, direction and obeys laws of vector addition. So here only we have given magnitude. Then what could be the direction of F? So the direction of this electrostatic force, direction of this electrostatic force is lie always along the line joining the charged particles. Line joining the charged particles. Means what? For example, let us see here, this is a charge of q1 and this is a charge, another charge of q2. It is positive in nature and negative in nature. Let us see that. So this is the line joining their centers. Then the force of attraction or repulsion, whatever it may be, in this case it is force of attraction, is acting along the line joining the two charged particles. This is the direction of electrostatic force. Okay, so then what is the vector form of electrostatic force? Vector form of electrostatic force. So it could be written as F is equal to 1 by 4 pi epsilon naught q1 q2 by r cube into r bar. Remember this. Here it is r cube into r bar. What is this r bar, sir? R bar is the position vector of the force experiencing particle with respect to force exerting particle. Do you understand what is R? R is the position vector of force experiencing particle with respect to the force exerting particle. So this is the vector form of Coulomb's law. See this, in magnitude F is inversely proportional to r square. Yes or no? In magnitude F is inversely proportional to r square. See here, F is inversely proportional to r square. In vector form, F is inversely proportional to r cube. Remember this. Many times in many competitive examinations ask this question. The vector form of Coulomb's law is inversely proportional to r cube, r square. Other options will be given. So it is r cube. Okay. Next, let us learn some more points regarding Coulomb's law. Okay. So let us learn some more important points regarding Coulomb's law, sir. So we learned what is Coulomb's law statement and formula, how to calculate Coulomb's electrostatic force, and what is the magnitude and what is the direction so far. Now what are the important points regarding this Coulomb's law? What points you remember when you are working with the Coulomb's law? Let us see that. The first point is this electrostatic force F depends on medium in which the charges are present. It depends on medium. F, electrostatic force F, depends on the medium in which the two charges are present. What does it mean, sir? So for example, let us take these are the two charges Q1 and Q2. These are placed in free space. These are placed in free space, or you can take it as air. These are placed in air. Then the formula will be what? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. This is the formula when the charges are in free space or in air. What, sir? If the same charges are placed in other medium, some other medium, like in water or in alcohol or in Coca-Cola or Pepsi, Thumbs Up, whatever you want. Okay, so the distance between them is not changed and the amount of charge is not changed, but the medium is changed. Then let us take this as f dash. Then it will be 1 by 4 pi epsilon naught into k into q1 q2 by r square. So what is this k, sir? This k is called dielectric constant of the medium. What is this? Dielectric constant of the medium. Generally in this formula also k will be there, but here the k value is 1 for air or free space, but here it is not 1. Then what will be the relation between these two forces? What is the new force related to F, whether it is increasing or decreasing? Let us see that. Then what I am doing is I am calculating F by F dash, F by F dash, so that is equal to, I will be getting what, sir? If I calculate this one by, I will be getting F. Very good. Then F dash is equal to F by K. So from this you tell me whether the force, new force, is decreasing or increasing compared to the initial force. Yes, it is decreasing. That means when a dielectric constant is introduced, means a medium whose dielectric constant K is introduced between the two charges, the electrostatic force between them is decreasing. So this force is decreasing by 1 by K times of initial force. Yes or no? F dash is equal to F by K, means 1 by K times of F, it is decreasing. So in this way it is depending on the medium. Okay, so here epsilon naught value also measured practically. I am giving that value also for your reference. In SI units, the epsilon naught value is 8.85 into 10 power minus 12. Okay, so what is epsilon naught, sir? Epsilon naught is known as permittivity of free space. What is that? Permittivity of free space. Okay, so this is how medium is affecting the force, electrostatic force acting between the two charged particles. So in this way one can calculate how the value of force will be changing when dielectric constant is introduced. That is the first point. And second point. The second point is the electrostatic force is an action reaction pair. It is an action reaction pair. So what is action reaction pair? So whenever you see this, you remember Newton's third law. Yes, very good. So what is Newton's third law? Yeah, for every action there will be an equal and opposite reaction. Here also action reaction pair exists. How? Let us see that. So suppose this is charge Q1 and this is another charge Q2, are separated by some distance. This is, let us take positive charge and negative charge. We know that these two charges apply force on each other. Now Q1 pulls Q2 with some force. Similarly, Q2 also pulls Q1 with some force. Yes or no? Because Q1 is attracting Q2, Q2 also attracting Q1. Right? So the force applied by Q1 on Q2 is taken as F12. The force applied by Q2 on Q1 is taken as F21. These two will be F12 and F21 will be equal but in opposite direction. Okay, this is only na action reaction pair means the two forces must act on two different objects and their magnitude should be equal and the direction is opposite. See that these are the two forces acting on two different objects. First condition satisfied, and second condition, the magnitude is equal and they are in opposite direction. Clear, sir? In this way we can say that the electrostatic force is action reaction pair. Clear? And the third property, the electrostatic force is conservative. It is conservative in nature. What is meant by conservative force? When can we say that a force is conservative? Very simple. So the work done by that force in a closed loop is 0, then that force is conservative in nature. Here also the electrostatic force is a conservative in nature. That means the work done by the electrostatic force on a charge in moving one round in a circular path is 0. For example, if I want to move a particular point charge in a circular path, okay, so if I start this particle here and moving up to this point in a closed loop, then the work done by the force, which force here? Coulomb force. Under the Coulomb force it is moving, then work done will be 0, then it is called a conservative force. It's okay. Next, the fourth point. Coming to fourth point is the force is a two-body interaction. What is that, sir? the force is remember this one, two body interaction. What does it mean? It means if there are 2 point charges q1 and q2, we know that there exists some force between these two. Let us take that is F1. Okay, when I place another charge q3, what happens? q3 applies force on q1, q3 applies force on q2. Let us take the force applied by q3 on q1 as F2 and q3 on q2 as F3, for example. Okay, these two forces F2 and F3 cannot alter F1, value of F1, means the introduction of third charge cannot change the force acting between the two charges. When I introduce this charge here or somewhere between also, that force cannot alter the force acting between the two charges. So if I write different charge, see here, this is q1 and this is q2 and this is q3. Okay, now the force acting on q1 can be written as force applied by third charge on first body plus force applied by second charge on first body. Understood? So in this way, first we calculate what is the force applied by q2 on q1, that one, plus what is the force applied by third body on first body charge. So in this way one can calculate net force acting on the charge also. So this is called, the force is a two body interaction only. Okay, now so if I take another charge, the force between two charges, initial two charges, will not change that force. It cannot alter that force, its value does not change. Clear? So these are the concepts of Coulomb's law and its applications. Now let us discuss how to solve problems by applying this Coulomb's law. Okay, right. So how to solving problems by using Coulomb's law. Okay, simple. First let us see if three charges are kept in a line, q1, q2, q3. These three charges are kept on a straight line. Okay, the distance between q1 and q2 is a. Let us take distance between q2 and q3 is b. Now I want to calculate net force on q1. Net force on q1. So simple, net force on q1 is nothing but what is the total force acting on q1 due to the two charges q2 and q3. Let us take q1 is positive, q2 also positive, q3 as negative. I am taking in this case. First simply let us see what are the forces acting on q1. Let us take this is q1. On q1, what is the force applied by q2 is attractive or repulsive? Repulsive force, means q2 is pushing q1, so that this will be the force applied by q2. I am taking this as F21. Understood? This is the force applied by second charge on the first charge. As the nature is same, it is a repulsive force, so that it is pushing that body. What about q3? q3 attracts q1 because it is a negative and it is a positive, so that it is attracting, means pulling towards each other. This is F31. Now what is the net force? Net force is F21 minus F31. Yes or no? This I will be writing very clearly, magnitude I will be taking. Magnitude of, means why I am keeping magnitude? I don't know which force is larger, which force is smaller. If I know which is larger, smaller, I will be taking larger force minus smaller force. Here I don't know, that's why I use a symbol modulus. So here we will be calculating F21, how? 1 by 4 pi epsilon naught let us take that as K or A, sorry, A into Q1 Q2 by A square. Similarly, F31 is A into Q3 into Q1 by B square. Now what is F, sir? F is the subtraction of these two forces. Can I take common A? Right, that is I'll be taking that Q1 Q2 by A square minus Q1 Q3 by B square. This is the force, net force on Q1. If you know the values, you can substitute and you can calculate very easily. Okay, what is the net force on Q2, sir? Let us say this is Q2. Here Q1 is attracting or repelling it. Q1 is attracting or repelling? Repelling. So this is the force applied by first body on the second body. What about Q3? Q3 attracts or repels? Attracts means it is pulling this. So this is also in this direction. What is this? F31. See, in this case both the forces are towards Q3. Q1 is repelling and Q3 is attracting. So what is the net force in this case? Net force is equal to F12 plus F31. Addition, because both are acting in the same direction. Here both are acting in opposite direction, that's why we subtract. Here both are acting in the same direction, so that we add. So by calculating F12 similarly and F31, we can calculate this. Similarly, net force on Q3 also we can calculate. Okay, you do it as homework for you. Right, that is one of the application. Now second, another model, let us see. For example, now the charges are placed on an equilateral triangle, vertices of an equilateral triangle. Okay, let us take here a charge Q1 at A, at B Q2, at C Q3, for example. Okay, this is a positive charge, this is also positive I am taking, this is negative in nature I am taking. Okay, the distance is A as I have taken, it is equilateral triangle, the angles are 60 degrees. Now I want to calculate net force on charge placed at A, means on Q1. How to calculate this? Now let us see that generally I am taking Q1, right? So Q2 Q1, what is the force? Attraction or repulsion? As these are same charges, repulsion means Q2 push the Q1. In which direction it pushes? The force acts along the line joining, means in this direction. So this is the direction of force. This I will be taking as F21. Understood, Nana? The direction of force. Yes. Now what about Q3? Q3 and Q1. Is it attraction or repulsion? Attraction, because this is negative and positive. It acts along the line joining. Okay. Then this is the force F31. Now what is the net force? Net force is the resultant of these two forces. How, sir? If they are in same direction we add, opposite direction subtract, but here there is some angle between them. They are not in the same direction, they are not in the opposite direction. In this case we will be using parallelogram law of, in this case we are using parallelogram law of vector addition. Okay, do you remember that? Yes. Now the net force is, net force F is root of F21 square plus F31 square plus 2 into F21 into F31 into cos theta. What is theta? Theta is the angle between the two vectors. Okay. What is the angle between these two vectors in this case? 120 degrees. So by using this equation, one can calculate the force acting here. Understood? Similarly, force acting on Q2 also you can calculate. So due to Q1, this will be this side downward, and due to Q3 this side, and angle is 120 degrees, you can calculate. Similarly this also. Okay, now in this way one can calculate net force acting on that. Similarly, let us see another one. What if charges are placed on a square on the corners of a square A, B, C, D? This is Q1, Q2, Q3 and Q4, plus, minus, minus, plus. So what is the net force on Q3? Let us take. Okay, so on Q3, what are the forces acting and what are the directions? Let us see first on Q1. First by Q1. So Q1 attracts, so it will be along the line joining. This is F1 3. Okay, next about 4 also attracting the third one, so it is also line joining that. This is F4 3. What about Q2? Q2 repels Q1 because negative and negative. In which direction it will be? It will be along the line joining, means in this direction will be that. So this is what, sir? F2 3. So first you calculate resultant force between these two. Okay, as the angle between them is 90 degrees, you will be getting a resultant force of F13 and F43. That will be along in this direction. Now let us take this as something F1. Now the resultant of F1 and F23 will be the net force acting on Q3. In this way you can calculate on Q2, Q3, anywhere. Clear? So in this way we can calculate Coulomb force. Right. So this is today's concept, and I upload a worksheet in the description of the video. From that link you can download the worksheet and the class papers as usual. Thank you.